We continue the chapter Work, Energy and Power. We are discussing the numericals based on conservation of energy. Let us see the next question. It is given that a ball bounces to 80% of its original height. Question number 2. A ball bounces to 80% of its original height. 80% of its original height. A ball bounces to 80% of its original height. What fraction of its mechanical energy? What fraction of its mechanical energy? What fraction of its mechanical energy is lost in each bounce? Is lost in each bounce. We are given a ball bounces to 80% of its original height. And what fraction of its mechanical energy is lost in each bounce? And where does this energy go? Where does this energy go? So a ball bounces to 80% of its original height. So what fraction of its mechanical energy is lost in each bounce? In each bounce, the fraction of the loss of its mechanical energy, and also we have to say that where does this energy go? So suppose the ball is dropped from a height h. Let the ball is dropped. Let the ball is dropped from height h. The ball is dropped from height h, then its initial potential energy. Then its initial potential energy, mgh. We have supposed that the ball is dropped from the height h. So at the height h, the initial potential energy is mgh. And potential energy after the first bounce. Potential energy after the first bounce. Potential energy after the first bounce. Well, 80% of its original height. 80% of its original height means mg into 80% of h means mg into 80 upon 100 into h. It means 1 0 cancel, 4 and 5. 4 mgh upon 5. So potential energy after first bounce is 4 by 5 mgh, which is equals to 0.20 mgh. 0.20 mgh. This is the potential energy after the first bounce. 0.20 mgh. Now the fraction of potential energy is in each box. Fraction of potential energy in each box is equals to 0.20 mgh upon initial potential energy, which was mgh. So the fraction is 0.20. So the result is 0.20. Fraction of mechanical energy is lost, and this energy is lost in the form of heat and sound. This energy is lost in the form of heat and sound. This energy is lost in the form of heat and sound, and the fraction of mechanical energy lost is 0.20. Now discuss one of the most important examples from NCERT. And the question is a body of mass 0.3 kg. A body of mass 0.3 kg. A body of mass 0.3 kg is taken up an inclined plane. Is taken up in an inclined plane. A body of mass 0.3 kg is taken up an inclined plane to length 10 meter. To length 10 meter. And height 5 meter. The mass of the body is given, which is taken up an inclined plane to length 10 meter and height 5 meter, and then allowed to slide down, and then allowed to slide down. Then allowed to slide down to the bottom again. To the bottom again. Body is allowed to slide down to the bottom again. The coefficient of friction between the body and the plane is 0.15. The coefficient of friction mu k equals to 0.15. So what is the work done by the gravitational force over the round tree? What is the work done? What is the work done? The first part of the question. What is the work done by the gravitational force over the round tree? We have given a body of mass 0.3 kg is taken up an inclined plane. There is an inclined plane which is inclined at an angle of theta, and the length of the plane is 10 meter. The length of the plane is 10 meter. And the height of the plane is 5 meter. Height of the plane is 5 meter and length of the plane is 10 meter. And body of mass 0.3 kg is taken up. Body is moving in upward direction. Body is going up. The external force acting on the body is F. The weight of the body, mg, acting vertically downward direction. Its normal reaction acts perpendicular to the surface. Normal reaction R acts perpendicular to the surface. So if this angle is theta, then this angle will also be theta. And mg must have two components. One is this component mg cos theta, and this component mg sin theta. Body is going up. Weight of the body mg acting downward. Since this angle is theta, so this angle is theta by mathematics, and there must be two components of mg. One is mg cos theta, another is mg sin theta. And the force of friction when the body is going up, the force of friction, the force of kinetic friction acting in downward direction. So we have given the mass of the body. Mass of the body 0.3 kg. This length, height is 5 meter, length is 10 meter, and coefficient of friction mu k is 0.15. Then we calculate the value of theta. So sin theta equals to perpendicular upon hypotenuse. Hypotenuse is 10. That is 1 by 2, and 1 by 2 means sin 30 degree. So we get the value of theta is 30 degree. Plane is inclined at an angle of theta equals to 30 degree with the horizontal. Now we have to calculate the work done by the gravitational force over the round trip. Means work done in going the body from bottom to the top and then to come back from top to the bottom. Work done in going a body from bottom to the top and then to return back to the bottom. This is the work done by the gravitational force over the round trip. So work done by the gravitational force in moving the body up an inclined plane. Firstly, we calculate work done by the gravitational force work done by the gravitational force in moving work done by the gravitational force in moving up an inclined plane. Moving up an inclined plane. So we know work done equals to force into displacement. Work done equals to force into displacement. So W equals to F into S. Work done equals to force into displacement. And the force, gravitational force, F is equals to mg sin theta. F is equals to mg sin theta. F is equals to mg sin theta. And body is going up, and the gravitational acceleration due to gravity acting in the downward direction, or the angle between force and displacement. If the body is going up, then the direction of displacement is in upward direction and the force acting in downward direction. So the angle between force and displacement is 180 degree, and work done W equals to Fs cos 180 degree, and cos 180 degree equals to -1. So W equals to Fs equals to F equals to mg sin theta, and minus sign comes because the angle between force and displacement is 180 degree, and cos 180 is equals to -1. So F equals to minus mg sin theta, and displacement is L. This is the length L. So displacement taken is L. Then put the value of M 0.3. The value of G is 9.8. Sin 30 degree into length is 10. So minus 0.3 into 9.8 into sin 30 1/2 means 0.5 into 10. And after solving all this value, we get minus 14.7 Joule. Minus 14.7 Joule. So this is the work done in going the body up an inclined plane, and the work done in moving the body down the inclined plane. This was work done W1, now W2 means work done in moving the body. Work done in moving the body down an inclined plane. Work done in moving the body down an inclined plane, which is positive because body is going in downward direction and gravitational force also acting in the same direction. So the angle between F and S is 0 degree, and Fs cos 0 degree 1. So F into S means mg sin theta into L. Rest of the values remain same, and we get the value 14.7 Joule. So total work done in the round trip. Total work done during the round trip. Total work done during the round trip is W1 plus W2, which is equals to minus 14.7 plus 14.7, and that is 0. So total work done by the gravitational force in a round trip is 0. So work done by the conservative force over one round trip is 0. Already we have studied in theory that work done over the round trip by conservative force is 0. And we know that gravitational force is conservative force. Work done over the round trip by the conservative force is 0. So this proves that work done by the gravitational force over the round trip or total work done by the gravitational force in a complete cycle over the round trip is always 0. Work done in going from bottom to top was minus 14.7 joule. Then work done in going from top to bottom, the direction gets changes. So the result will be plus 14.7 joule and total work done minus 14.7 plus 14.7. It will be 0. And we know that work done by the conservative force over round trip is 0, so the result will be 0. Now the next part of the question. This was the first part of the question, work done over the round trip. Work done over the round trip equals to 0. Work done over the round trip is 0. Now the next part of the question. The second part of the question is work done by the applied force over the upward journey. Work done by the applied force. Work done by the applied force. Over the upward journey. The next part we have to calculate work done by the applied force over the upward journey. So work done by the applied force is F acting in upward direction, mg sin theta and Fk acts in downward direction. So work done by the applied force in going up, WA, work done by the applied force, and work done equals to force into displacement. Force into displacement. So firstly we calculate the force. Force acting on the body in going up. Force acting on the body. Force acting on the body during upward journey. So in forward direction the force acting is F, and in downward direction there are two forces act, mg sin theta and Fk. So F equals to mg sin theta and plus Fk. Fk is the force of kinetic friction. So mg sin theta and Fk is written as mu k into r. equals to mu into R. So mg sin theta plus mu k, and R equals to mg cos theta. So at the place of R, we use mg cos theta. From both the terms, mg is taken common. So sin theta plus mu k cos theta. This is the applied force, and work done equals to force into displacement. Work done equals to F into S. So force is mg sin theta plus mu k cos theta, and S displacement is L, length. Now put the value of mass 0.3, G 9.8, sin 30 degree means sin 30 degree 1 by 2, 0.5. The value of mu k is 0.15 and L is 10. So 0.3 into 9.8 into 0.65 into 10. And after solving these values, we get the result 0.18.5 mu k cos theta, mu sin theta plus mu k 0.15 into the value of cos theta, cos 30 degree. Cos 30 degree is root 3 by 2. So 0.15 into root 3 by 2 into 10. So 0.5 plus 0.15 into root 3 by 2 into 10. And after solving, we get the result 18.5 joule. 18.5 joule. So this is the work done during the upward journey. Work done during the upward journey by the applied force. Upward journey by the applied force 18.5 joule. So this is the second part of the question. Work done during the upward journey by the applied force. So firstly we calculate force acting on the body during upward journey, and applied force is F equals to mg sin theta plus Fk, and Fk is equals to mu k into R, and R is equals to mg cos theta. So mu k mg cos theta, mg is taken common, then we use the formula for work done, force into displacement. Then put the values, and the rest part of this question we'll do in the next video.